Interface. An interface is something like a class, but it's not a class. It's something you can add to a class, and it forces the class. It forces you to create certain methods. That's basically what the syntax does. It can do a bit more, but let's start from reading the wiki, and you will understand, and then we will implement something. An interface in the Java programming language is an abstract type that is used to specify a behavior that classes must implement. Basically what I said. It's something that you add to a class and it forces you to create, how do they call it? Behaviors. I don't expect you to understand it or start using it or implementing it or making something logical out of it. I just want to show you the syntax. Let's see what the Java doc has to say. There are a number of situations in software engineering when it's important for this separate group of programmers to agree to a contract that spells out how their software interacts. Each group should be able to write their code without any knowledge of how the other group's code is written. Generally speaking, interfaces are such contracts. What they're describing here is basically a situation where you're working in a company and in a production environment where you have different teams that develop the same software, and they share their classes between each other, and the class is like a black box. You don't need to see the code to use it. You can use the black class and the method say something without knowing what it does. And here what they're saying is that interfaces are basically forcing other teams to conform to some norm. Let's say in your API you must have these 4 methods with these arguments, etc., etc. So the interface, basically when you add it to a class you want to add to the project, it forces you to add methods that you must implement. And then when other people use it, they know, let's say, if they have a black class and they know that the interface has a get name method, they can use the get name and they know they will get the name from, or whatever they expect from the black class, no matter who developed it. That's basically the philosophy behind it. Do you need it now? As a beginner? No. Will you need to learn about it in the future? Yes. Do you need to know how the interface syntax works? Absolutely. That's what I'm teaching you here. I'm not going to teach you a practical example. You can search for Google for practical example of a Java interface. Good luck with that. You won't find any. Well, if you do a long research, you might find something, but not at a glance. So what we'll do now is show you how an interface works, basically. How the syntax works, not how to use it practically. Okay, let's begin after the long introduction. We will create a class by clicking here, near the package at the top. It's next to the plus symbols. You can also go to click the package in the sidebar and then go to new and then click on class. So when we click on class, we will create a new class called sample. That's a sample class for our project. It's a class that will be empty. and it will only implement a few interfaces. Let's create interfaces now. We do the same thing. We right click on the package we want to add the interface to. We go to new, and then we select interface. And this interface will be named, let's say, calc. Let's do an interface named calc. It will, if you can guess, it will do calculations. And let's add another interface and call it, say, stuff. So when inside an interface, let's start with let's do the calc. So inside the interface, you can declare methods, but not their execution. Let me show you. Let's say a plus method, public plus, and it will have an int x and int y. We have seen this before. And then we add a semicolon at the end. Let's see, we didn't give it a return type. Let's say a return type of int. And that's it. We don't have an error anymore. That's how you declare a method that will be forced on whoever uses this interface. They will have to implement this method, but we don't have to. Let's try to implement it, and we'll get an error. Abstract methods do not specify a body, an execution body. You can add a default keyword. We'll show you that later, but for now I want to show you a simple implementation of how to declare a method in an interface. So this is the plus method. It doesn't have a body, it doesn't have an execution. So if we go to our sample class to add the calc interface, let's save it first. We will write implements with an E, and then we will write calc. And now it will show us that there's an error beneath the class name. This type sample, our class name, must implement the inherited abstract method calc plus int. What it tells us that we must implement this method that we declared here in the interface. So there's an easy way to do it. Add unimplemented methods. And it adds it for us. Doesn't look like much, right? Okay, let me show you something. Let's say we had 3 methods, minus and multiply. Now we have 3 methods we must implement in our sample class. Are we going to write them by hand? It's going to be long. So we hover the sample and click Add Unimplemented Methods. Ta-da! It implemented the 3 classes we had to implement. It basically got the visibility of the method, the return type, name, and argument, and just added the execute clause to it, the curly brackets, and the return 0, so it will return some kind of int, because if we don't have this, we'll have an error. This method must return a result of type int. Let's click Ctrl Z to return it, and we can remove this thing. So basically, now we can leave it like that. We already did what we had to do with the calc interface. We implemented the 3 methods we needed to implement. Let's say, again, in the company example, we we have those, how did they call it, contracts or rules we have to follow when creating a class of a certain type. Let's say sample is a type of calc. It must implement methods like this because this is our API, the application programming interface. This is how our API works. It uses methods like this. In classes that do calculations, they must have a plus method, a minus method, and a multiply method. In case some other programmer from our company wants to use sample, he won't need to come inside here and look at the code. He will just create an instance of sample. Let's say we are that programmer. Sample s, new sample, and then he will just call s.plus. That's it, and he will write 1 and 2, and it will do some kind of calculation. It doesn't know what calculation it will do. Let's put it in an int. Yeah, and I don't have to know what sample does. Well, I do have to know what it does, but I don't have to know what code it has inside of it. Because the calc interface has these 3 methods, I know that sample also has these 3 methods because it implements this interface. This interface. So I can use plus, minus, and multiply in every class that implements interface. And I don't have to look at the code. I just know it works. Or does what it's supposed to do. Let's implement it for fun. X plus y. And here we'll do x minus y. And here we'll do x and multiply it by y. The star character is for multiplication. 2 multiplied by 2 is 4, etc., etc. Let's output it and see what it does. Let's output x and see if it will add 1 plus 2. s.o x. Yeah, 1 plus 2 equals 3. And let's go to say stuff and show you more functionality of the interface. An interface can also have default methods that do stuff. Let's say public void say. And here we can add the curly brackets, but it will have an error. Let's see it again. Abstract methods do not specify a body, except if they have a default after the visibility. Now we can use our s.o and say blah. Okay, and let's add it. We add say stuff after the calc, and it will implement both calc, say stuff, and whatever other interface we will have. They have to be separated by a comma. So now sample also has the method say. Doesn't seem very useful because it only says blah, but you can also have methods that have, let's say, arguments that can get stuff and do stuff with them. This can be very useful if you need to add some kind of, let's say, a mutual functionality that will be used by all interfaces. This can be very useful. You can also use a static class with this thing as a static method, but this is another way to do it. Let's say blah. s.say. Now we can use say. Even if it's not, you don't see it here, it will work. You will see. Say blah. We can also use it inside plus. Let's say say. We use it as if it's a part of sample, but it's actually a part of the interface say stuff. Yeah, it said blah before the calculation because we added it here. Let's say stuff had another method, probably void something. Now, when I save it, there will be an error in sample. What's the error? The type sample must implement inherited abstract method sayStuff.something. And again, we'll just click add unimplemented method. And it's supposed to, yeah, it added something. Now we must implement it. We can leave it like that. But yeah, now we have another method we must implement because we added it to sayStuff. And as it said, we have a contract with the interface that forces us to implement its specified methods in the class that we added the interface to. And you can also create default methods to an interface, and that's kind of it. It's nothing special. It's nothing complicated. It's not. I think the ifs tutorials, the if lessons were more complex than this. This is just another syntax that Java has that I wanted you to see and learn. There's not much more to it. That's basically what it is. For now, that's all you need. In the future, when we will use interfaces, maybe Java's default interfaces or other APIs interfaces, you will see practical uses of it. But for now, I just wanted you to see the syntax. If you don't understand anything, you can contact me via the Q&A. And that's it for this lesson.